challenges we face as a planet can be summed up simply. We need to provide reliable and affordable energy to our growing population while also addressing the risk of climate change. Natural gas provides energy to the world. When compared to coal, it emits up to 60% fewer greenhouse gases and produces fewer air pollutants for power generation. The issue isn't just one of production, but also one of transportation. Shipping liquefied natural gas, or LNG, isn't like shipping sneakers. Efficient shipping is absolutely critical. LNG needs to arrive on time, or people could run out of power. The global LNG industry today involves thousands of voyages a year across the globe. To handle the scheduling in a global supply chain over a year, you must account for the positions of each ship on each day of the year while satisfying requirements for hundreds of deliveries across the world. This problem can involve millions of discrete decisions, which means the number of routing combinations we would need to consider would be larger than the number of atoms that exist in the universe. The problem becomes even more challenging if you go to a much larger fleet or introduce uncertainty like disruptions due to weather or fluctuations in demand. Then you're talking about billions or even trillions of discrete decisions. There currently isn't a computer on the planet powerful enough to do this without greatly simplifying the problem. At least not yet.
Quantum computers allow us to view incredibly difficult problems with a fresh set of eyes. We've been conditioned in many cases to simply not consider problems with an incredibly large number of variables or potential solutions. Quantum computers completely change the model by which we can perform information processing. Instead of with classical bits with zeros and ones, we have quantum bits, or qubits, that follow the natural laws of quantum mechanics. The point is, we're not dealing with just flipping zeros and ones anymore. And instead, we have a rich set of rules that governs our computations, allowing for the exploration of an exponentially larger computational space.
Working in partnership with IBM Quantum, ExxonMobil Corporate Strategic Research has been exploring how to model maritime inventory routing on quantum devices. We've looked at the strengths of different mathematical approaches in quantum solvers, including how well they account for complex real-world constraints like limits on ship sizes and timing of when ships need to arrive and depart. These mathematical models could also be relevant to other vehicle routing problems, including goods delivery, ride-sharing services, and urban waste management.
Today, IBM already has over 20 quantum computers across the world, running over 1 billion executions a day on the IBM cloud. We've opened up this technology so that everyone can sign up and experiment with it. And so far, that means 300,000 users.
By partnering with IBM Quantum, our aim is to ultimately level up our ability to tackle more complex optimizations and make bigger differences. We believe these will provide different ways of thinking about the dual challenge we face now and the ones we will tackle in the foreseeable future.